Okay, so this week we are changing things up a little bit. So we will be taking our last pause from JavaScript that you will get until the end of the break. So hopefully everyone had a chance to catch up on their homework assignments. Hopefully everyone had a chance to use that review week, get a leg up on your capstone. I know a lot of you guys have scheduled one-on-ones with me or showed me your progress. So the good news is the vast majority of you are on track to meet all of those capstone requirements. So that is good news. Have more details coming for you next week about graduation, which is the first Thursday in October. I think it's October 3rd. Don't quote me on that date. So we'll get you more details about that. Get an invite posted so you can invite friends and family and get you more details. We will be changing it up from previous graduations. I don't know if any of you had seen them, but instead of putting you on stage for 6 minutes, which is a really tight time and takes a long time to get you guys all through, instead what we'll be doing is like a minute demo video of each one of your capstones, and then we'll be opening it up for like employers and friends and family to be able to kind of wander around table to table and get a demo of your capstone and have you guys talk about that. So it's going to be a slightly different format than everyone presenting on stage. Hopefully, will be a little less nerve-wracking. But if you want to think about it kind of more as like a career fair, right, where like you guys can wander up and talk to employers, we'll be doing that in reverse. So you guys will all have your own little table. We'll do that for an hour, hour and a half, and then there will be refreshments and all of that kind of stuff as well. So that is where we are headed. Asma, you have a question.
Yes, for the 1 minute demo, is it going to be pre-recorded video? Okay.
Pre-recorded video and less about a demo and more just about talking about your project inspiration. So it will be more of like, and I'll have more details about this coming down the pipeline, but more about like why people should come over and talk to you and learn about your project. So you're not trying to fit everything down into a minute, but it's more of just, hey, I'm going to be over at this table number and here's my project idea, and if you want to learn more about it, here's where to find me, kind of thing. And then you'll have the opportunity to demo live on your laptop. Choose if you want to have them play around with it directly, or instead you could choose to like walk people through it and talk to them directly. But it's more of a an opportunity to like talk to someone than it is everyone like lecturing for 6 minutes about their project, kind of. Terry.
Yeah, is it gonna be like some like kind of like a science fair thing? You know how where they got like the table set out and they explain like they project and stuff. Is it gonna be kind of similar to that?
Exactly like
Okay.
that, yes. Um, just because we've now done five of these graduations, right? And even though 6 minutes doesn't sound like a lot of time, when you multiply that by the number of students, it really adds up. And then there's a whole order thing that we've got to do, and then people run out of time. And anyway, so we're going to try this new format in hopes that we get more engagement, right? In terms of employers coming out, learning about not only your projects and what you built, but have an opportunity to talk to you. It gives friends and family really an opportunity to get hands-on with your application. It gives you the experience of actually interacting and talking about your project without having to have the fright of getting on stage and showing it off. So I think that this format will be better. But if you guys have any feedback on it, feel free to shoot me a Slack message, or if you have any ideas, because we haven't locked into anything quite yet. And if you're like, no, I really want to spend 6 minutes on stage presenting my idea, that idea is, or that format is definitely not off the table either. So I believe what we'll be doing instead is doors will open at 5:30. We'll do like a little kickoff presentation at 6. I will talk a little bit about what you guys have learned over the whole cohort. We will play everyone's videos, which will take about 15-ish minutes, 1 minute each, and I'll give you guys a list of not only how to record the video as we get closer, but what should be in it. And then we will like open up the floor. We'll send you guys to your table numbers. So we'll have numbers at every table. We'll have you positioned at them. We'll have people mingle for an hour-ish. And then we will call your names. You'll walk across the stage. We'll get a group photo at the end, and then that will be the end of it. And light refreshments and cake and stuff will be provided. And that will all be at Lemoyne the last Thursday of the program. Let me get the date. But the same place we held kickoff will be the same place we held kickoff will be James Commons. It is indeed the 3rd, October 3rd. And we'll have a meetup link there where you can RSVP so we have an idea of how many people will be there and how much cake to buy as well. Any questions about where we're headed, about assignments in Canvas, about where you guys are at on your capstones, about anything? We will be getting into SQL next. This week will be a little different from everything else. We will be picking up JavaScript actually probably by Wednesday or Thursday. But the next 2 days we will be spending on SQL, which is an entirely different language, and the last new language you'll be using. So it's not technically a programming language, but we're going to be using Khan Academy to learn SQL. And then we'll be learning in the second half of the week how to pull in databases into JavaScript. So it is very important to learn about SQL because if you wanted to get into full-time database, either database engineer or database administrator, you would be working with SQL directly. But that is where we will be heading into next. So opening the floor to any questions before we get started on Khan Academy tonight. Yes, Terry.
How is this week going to be different from our previous week? What do you mean by that?
Yeah, so we won't be writing any, at least for the first 2 or 3 days, we won't be writing any JavaScript. So instead of me opening up, me sharing my screen and starting a new project and writing some code and having an end goal, we're going to be spending the first 2 days in Khan Academy and watching their videos. And then after the video is done, I will like pause it and kind of talk through what they just said and what the important parts of it are. Then we will be doing their exercises that are built into the SQL course. And then on Wednesday, we will actually get it SQL set up on our computer. We'll do some of that. We'll do database design. So for the first time in a long time, I'll actually be talking through slides about how to design a database, all of that kind of stuff. And then by Thursday, we will start talking about how SQL works in Node, how we connect to the database, and getting our first API set up. So we'll be back to kind of the regular format by Wednesday, Thursday-ish, but the first 2 days we will be doing in Khan Academy. And to give you more context is why I do Khan Academy. So if you take SQL in college, they usually break it up into 2 separate courses. So you spend an entire semester on database syntax and database querying, which is the SQL language, standardized or structured query language. I've heard both of them. And then you spend another entire semester on database design. And that can be beneficial if you are designing a huge database or you're working for an organization that has thousands and thousands of tables. But I have never needed more than about the first 3 weeks of what I learned in SQL programming, and about 3 weeks of what I learned in database design. And everything after that, as a full stack web application developer who has always used databases for 10 years, I've never needed anything really fancier than that. So the reason why we do Khan Academy is I think they do a really good job of saying, hey, this is really what you need for SQL 101. This is what you need to like just get started in SQL. And then the database design stuff, I've come up with my own slides to say like, hey, if you get these basic concepts, this is all you will really need to know how to do. So there is an assignment in Canvas to create a ERD, an entity relationship diagram, which is basically a flow chart of how your database is designed, the different columns you'll be having, all of that kind of stuff. The assignment probably won't make any sense to you until Wednesday or Thursday. So don't worry too much about getting that done. And the reason why I keep on saying Wednesday or Thursday is because the last time we did this week, we only had 3 out of 4 days. So the timing I'm a little unsure of, but we're going to try and get through Khan Academy on the first 2 days. That will be your intro to SQL. And then day 3 and 4 will be database design and then actually getting hands-on, getting it running. And then we will transition after this week into full stack application development. Things on my radar, doing a demo with React Router and the nav bar, because I know a lot of you guys have nav bars in your projects. Ryan will be coming back in a week or two to do, I think 2 weeks, to do login and authentication with you guys. So I know that's coming down the pipeline. If you have either nav bars or logins in your capstones, that is okay to kind of hold off on until we do those demos in class. And then same goes for your database design. After this week, you will have everything that you need to know to get started on your database. Not saying by Thursday you need to have your database fully finished, but you'll be able to get started on the table design, figuring out what will be stored in your database. You'll send me your ERDs, which we'll learn about again second half of this week. I will get you feedback on them. You'll be able to start loading your database up with data. And then by the end of this module, Nathan comes back in and we'll start teaching you guys about deploying your applications, your full stack applications, your servers, your databases, all of that stuff to a platform called fly.io. Any other questions? Okay. I am going to share the link with you guys to the Khan Academy. I will also say that you guys have an opportunity to actually get out of class if you would like to go through these on your own. So if you would prefer to not sit through this while we're screen sharing and talking through it, you can complete each one of these challenges all the way through to the bottom here. You do not need to do the projects. You only need to do the challenges. So if you decide, hey, I think Max's voice is super annoying and I can go through all of these videos on my own, if you send me a screenshot that each one of these challenges is complete, you do not have to show up to class until Wednesday, because we'll be spending the next 2 days going through these videos, giving you guys a couple minutes to work on the challenges, and then moving through onto the next one.
Could you go over which ones we need again?
Yeah, so basically everything in Unit 3, the videos and the challenges, but not the projects. And so the challenges look something like this. And you'll see there are 3 steps in each one of them. They give you a task for you to do. They give you a little hint at the top. You figure out how to do that task. It will ungray out the next step button once you get that task done. And then you just need to send me a screenshot that you got like all 3 steps done for this challenge. Or I think a little check mark shows up on the challenge if you go back to the list screen. So you could basically just screenshot this whole section.
Gotcha. Do you know if anything has changed since cohort 5? Because I think I followed along with most of the stuff then.
As far as I know, everything is still the same as cohort 5.
Okay. I think I'm gonna go through it again anyway, but
Cool. And it's also fine to like do 2 or 3 of them in class and then decide that you want to just get them done before Wednesday's class, and peace out. Let's do attendance now before I forget. The secret word for tonight is going to be query. Query. Once you guys are done with attendance, go ahead and pop open the link that I put. Did I put it in the chat? I thought I put it in the chat. Yes, that I put in the chat. And I would recommend that you sign up for a free account, because that's going to save your progress as you're working on it. It's not an absolute requirement to have an account, but I would recommend it. I'm actually going to log into my account. And so now that I'm in my account, you guys can see what the finished challenges look like. They've got like that little check mark on them. So you could just like screenshot this entire section and then just shoot me a Slack message. I don't think I have it in Canvas, but I will double check. Yeah, so if you want attendance credit tomorrow, just shoot me a screenshot that the messages are that you're done with that. Okay, let's go ahead and dive on into these videos.
The world is full of data. Every app that you use is full of data. On Khan Academy, we store data about users and badges and progress. On Facebook, they store data about who you are, who your friends are, what they're posting. On Bank of America, they store data about how much money you have and what accounts that's in. How do these apps store data? Well, they use a database, which is a program that helps store data and provides functionality for adding, modifying, and querying that data, and doing that all fast. Databases come in many forms, but a really popular type of database is called a relational database. It stores each kind of data in a table, which is kind of like storing data in a spreadsheet. A row represents an item, and a column represents properties about that item. For example, to store data about Khan Academy users, we'd have a users table with a row for each user and columns for properties like their nickname and location. Relational databases make it particularly easy to form relationships between tables. For example, in order to store Khan Academy users and their badges, we might have a users table and a badges table, and then a user badges table to remember which users earned which badges, just by mapping user IDs to badge IDs. That's a more efficient form of storage than having to repeat everything about the user and everything about the badge in the user badges table. Most databases come with a query language to interact with the database. SQL is a language designed entirely for accessing databases and is the most popular of them. With SQL, we can create tables, change data, get back to data that we're interested in, like we want to find out which users joined in the last week or which users have a particular badge. That's what we're going to teach here, and you'll actually get to try out SQL here in the browser using SQLite, a particular implementation of it. You won't be able to write the whole app here, but when you're done learning SQL, you'll have a much better understanding of how data is stored in the apps that you use and be able to use SQL if you ever build an app.
Okay, so one thing that they don't mention here is they talk about relational databases. They don't talk really about the other kind of databases, which are very uniquely named non-relational databases. I'm not joking, that's literally what they call them. Relational databases have been around since the 60s and 70s. The four most popular variants of SQL databases that you may have heard of are MySQL and its cousin Maria DB or Maria SQL, Postgres, which is what we will be using in class, or PostgreSQL because they double the S for SQL, Microsoft SQL Server, Oracle SQL Server, and I think those are the four majors. MariaDB and MySQL are kind of interrelated. So those are the four ones: MySQL, Postgres, Microsoft SQL Server, and Oracle SQL. There is also a very common other type of database, a non-relational database. Does anyone know the name of that? The very popular non-relational database?
Mongo?
Mongo, yes. So Mongo is kind of different in that instead of storing all of its information in tables, right, where the columns are basically the table structure and then the rows are all of the data that were inserted, inserting Mongo instead uses something called documents to hold all of its data. So if you want to kind of oversimplify Mongo, instead of storing the data relationally, it nests the data in the database. So you can think about Mongo as basically a very powerful place to store JSON documents. It's not exactly JSON, but it uses a very similar format. So why do we teach SQL then if Mongo can just store JSON and we already know how to work with JSON? Well, in this area, in the Syracuse area in particular, most companies are still using SQL, and I believe SQL still has the majority of the market share. So SQL is even more universal than something like programming languages, right? So learning SQL and then switching between Oracle and Microsoft is going to be very, very easy to do compared to learning a different programming language, which is still easy, but different syntax and that kind of stuff. For the most part, that is standardized across the SQL world. So we don't teach Mongo. However, it is a little different than SQL because SQL has the market share still. That's what we teach. However, these concepts are still pretty relatable. And if you end up working at a company that is using Mongo instead of a relational database, I would highly recommend looking up a guide for like SQL to Mongo concepts. And there are a lot of great diagrams or a lot of great terminology to say, oh, what we would consider a row in SQL is what we would call a document in Mongo, or what we call a table in SQL is what we call a collection in Mongo. So there's a lot of overlap between them and a lot of similar concepts, slightly different terms. We teach SQL just because it's widely used in the area. I promise you I won't be talking as much on each one of these videos, but just wanted to give you a little context. Any questions before we keep going? Okay.
Welcome to my database. It has no data in it yet because I want to build it up with you. What sort of data should we store in our first table? Let's start with a grocery list, which you've probably used in real life. I'm pasting an example list, which has 3 delicious items and how much we want to buy of each of them. Our first bit of SQL will be the command to make the table to store this list. I'll write create table in all caps, and then the name of the table, groceries, and then parentheses and a semicolon. We see an error pop up because the SQL interpreter expects to see column names inside these parentheses. What column should we have in order to describe each item on our list? Well, first we need a name for the item, which I'll call name. And we need to follow that with a data type. We have a few options. Let's go for text. If we look on the right-hand side, we can see our new table is listed with 1 column. But we also need to specify how many of each thing to buy, like our 4 bananas. So let's add a quantity column as well. And this will always have a whole number, so let's use an integer for that data type. And now we can see that new column listed in our table. That looks pretty good if we're thinking about what data we have in this grocery list, but we're missing something that we need in databases, a unique identifier for each row. We almost always need unique IDs for each row in a database because we need a way to identify rows later when we're updating or deleting them and not be dependent on other columns because those could change. We typically specify this ID column first, so I'm moving my cursor before name. I'll call this column ID, that's standard, and then for the data type, I'll have to write this phrase, integer primary key, which signals to the database that it should treat this as the row identifier and that each row must have a unique value for this column. Okay, now we have our groceries table with 3 columns in it. It's empty though, so let's put some data in it. We'll write insert into, and then the table name, groceries, then values, and then parentheses. And here we start listing the column values in the order that we declared the columns. The first column was ID, so I'll put 1, so we haven't used that ID yet. The second column is name, so I'll write bananas. And the third column was quantity, so I'll write 4. Do you see how the schema updated on the right? It now says that there's 1 row in the groceries table, so our insertion worked. Let's add the next 2 items and just doing the same thing. Insert into groceries, values, 2 peanut butter. I want just 1 of those because otherwise I eat too much. And insert into groceries, values, and ID 3. Dark chocolate bars have to be dark. Milk chocolate is not even chocolate. And we'll get 2 of those. Okay, so it says 3 rows, but to really see that the database actually contains data, you can click the table name on the right. This will insert a select statement in your code. And don't worry too much about this now because we'll get to it in the next video. If you want, you can pause the talk through and try clicking the table name yourself to see what happens. That's it. That's all we needed to create our first table and add data to it. It's pretty cool, huh? In the next section, we'll see how to get the data back out of the table in more interesting ways.
Okay, so data types super important in our databases. Every database that we use, Postgres or MS SQL or SQLite, that's the other major SQL variation I forgot about earlier. They all have their own slight different variations on data types, but for the most part, we're working with integers or strings or text, or doubles, which will have decimal points in it, or booleans. Those are the major types. So what we're doing here is we're saying create table. We can't insert any data into the database unless it's going into a specific table. We name the table, and then we give it the structure of that table, right? So we say ID is the column name, and then integer is the data type. Once we are done with that query, we can see the result of the schema. Schema is basically the structure of the table that we created. Afterwards, in order to insert rows into that table, we say values, so it knows we want to insert what do we want to insert into the row. We use the ID, and then we give it the rest of the data associated with that. That means by the time we have run 1, 2, 3, 4 queries here, the data has been inserted, but we can't really see the output of that table until we run the select query. The select query is basically saying, hey, go read something from the database. The star means go get all columns. From is a keyword, and then groceries is the table name. So we're able to see the result of the query here. SQL is a language for sure. SQL stands for Structured Query Language, so it is certainly a language. It does not count as a programming language, just like HTML is not a programming language, right? HTML is technically a markup language. In other words, it is a way to mark up our content so that we can structure it on the HTML page and apply styling to it and all of that kind of stuff, right? Because SQL is not a programming language, it is technically a querying language. Mongo has a querying language as well. But we could think about it more as a database language, which is a lot more accurate or a little bit more broad. So yes, a language, but no to a programming language. Okay, any questions on this? Okay, so I'm going to be using a lot of polls tonight. Go ahead and pop open the Khan Academy link. Again, if you have not created an account yet or signed in, I recommend you do that so it will save your progress as you go. You can go over to the challenge book list database, and then right up here at the top, so it will give you the challenge. What are your favorite books? Make a database table to store in them. In the first step, create a table to create your list of books. It should have columns for ID, name, and rating. They do give you a little hint up here to move on to the next step. And then the final tip that I have is if you go back to the video right before it, it annoyingly doesn't show you any of the code. If you fast forward the video down here until the end, it will basically fill in all of the code so you can reference that previous step to get practice on to the next step. So go to the previous video, fast forward it all the way to the end, and you can see all of those answers. So go ahead and work on this. Once you get this step done, the next step button will light up. There will be a second set of instructions to do. Go ahead and finish that. And then when you do have that finished, go ahead and vote. Go ahead and vote that you are ready to move on to the next one in poll. Only vote when you have both steps done or all three if we're on a video that does that. Joe, your video doesn't need to show that a check that it's done. Only the challenges need to have a check for if you're like skipping ahead.
Is double just double for the variable
Um,
tag?
they use SQLite in Khan Academy under the hood. It is a real REAL in SQLite.
Gotcha.
They may not take that as an accepted answer. You may have to use integer, but
Oh, I got all the other stuff done. I was just doing the project for lesson one.
cool. Give you guys one more minute, and then we will go through the answer together.
Is are booleans not stored as
Maybe just bool, BOOL. Oh,
I'm reading
um,
that it's stored as a 0 or a 1 as an integer.
that is correct in SQLite. In all the other databases, they actually have Boolean as a data type, but Booleans are just stored as 0 or 1, but will recognize the values true and false in your query. But they do
Oh,
store it as 0 or 1.
so if you were to call that wrong in your code, you could get some funky results if you use
Yeah,
SQLite.
using SQLite if you're not using an ORM, which we will be teaching you guys how to use. But the database driver itself may fix that for you. Okay, let's go through some of these answers. So first step is to create a table. So we use the keyword create table. And then we need to give it a name of the table. So we will call the table books. And then it needs to know the data structure of the table. So we are going to say ID, and ID is usually an integer. We are going to do the name column, which will be text. And then we will also do the rating, which we will also do as an integer. Now we move on to step 2, which says now add 3 books into the table. So we'll say insert into books, and then we need to give it an ID. We will give a book title of title 1, and then we need to give it a rating. And then, of course, we can copy and paste this 2 more times, change the IDs, change the book titles, change the ratings. And don't forget the word values. What did I do wrong? semicolon after create table, and we are good to go. Any questions on that? Okay. On to the next challenge or the next video.
We're back with our groceries table, but we've expanded on it a bit. It now has a column for which aisle number we can find the item at the supermarket, plus we've added a few more items. Now you can really see the power of SQL in different ways that you can retrieve data from your database. And this is also where it can get a bit tricky. To start off simple, how would we retrieve all the rows from our table? To perform any query, we write select, and then which columns we're interested in, like the name, and then from, and the table name that we're selecting from. And we can see a list of the groceries on the right under that results section. But what if we want all of the column names? We can just replace name with star. And that was also the query that got inserted when you click the table name, which you might remember from the first talk through. This list is out of order though. If we went from top to bottom at the store with this list, we'd have to keep changing aisles. We'd rather have it ordered by aisle so that we can be more efficient at the store. To do that, we can just add an order by clause to our query, specifying which column we want to order by. Ah, that's better. Now we can get our ingredients faster. But to be even more efficient, my brother and I like to shop together and split the store so that I shop in half the store, he shops in the other half, and we meet at the checkout. There are 12 aisles at this grocery store, so for my list, I just want to know which items are in aisles 6 through 12. Well, anytime we want to filter results out, we can use a where clause for this and specify the column name and then what we want to compare it to. So in this case, I used a greater than operator, but there's lots of different comparison operators depending on what it is we're trying to filter by. Great. So now I know exactly what items I'm going to get. I'm going to be really efficient. And you've learned a few ways to use SQL to query. Now stay tuned to find out even more ways that you can select.
Mo asked a good question. Why didn't we use integer primary key in this last example? That is a good thing to add, especially when you're working with relational data. So I will add it into my solution. You can see it's not required for this particular one, but by adding the primary key onto it, it tells the database it should generate the ID for us if we forget to put it in. And it also says, hey, when we're relating this data to other tables, this is the column that we're using, and the database kind of optimizes the table under the hood for that in the storage. So adding primary key is a really good idea, although it's not always required. If it is in fact the primary key, in other words, how we look things up in the table using that ID, we should add it. It's kind of like the key in React code when we're mapping over things. If we don't add it, our React code will still work, but it will work more efficiently if we add in the key. The same goes for the database. Okay. I'm gonna clear this answer so you guys don't see that. So next challenge, go ahead and get the results back out of the database in different ways. In the first step, just select all the movies. The next one is pretty easy as well. I'm going to go ahead and relaunch the poll. Go ahead and work on the box office hits database challenge. Vote in Zoom when you are done on both steps. Don't forget to vote in Zoom. Give you guys 1 more minute and then we'll dive into the answers. All right, most of you guys have voted in. First one's pretty easy. Select is the keyword that we use to select data out of the database, basically retrieve a certain set of data. The star is going to be the universal command for select all of the columns. And then we need to say from and give it the table name, which is movies. That pulls back all of the data. For the next one, we only want to leave the first select statement. We're not modifying it because it says you should have 2 select statements at the end. And we only want to get the movies released in the year 2000 or later and not anything before. And then we need to order it. So we're still going to select star from movies. We are going to add a filter to that, which is the where keyword, and say the column name release year is greater than 2000. Which takes care of the first part. And then we also need to sort it. So we're going to use another keyword, order by release year. And that
You did put movies.
thank you. That gets the query working for us. Now, SQL is kind of like JavaScript. It doesn't really care about white spaces. So if this kind of looks ugly to you, or as we start building up more advanced queries, it will know that the query is still going until it reaches that semicolon. So if you prefer to write your query like this and put the keywords all on their own line, that is also totally acceptable. Any questions on that? Okay. I'm gonna go ahead and finish that off. And move on to aggregating data.
We're back with our grocery list. I can see that it has 6 rows in it, but I can also see that we need to buy more than one of each item, like our bananas. So I'm not sure offhand how many items we'll end up buying total. And I'd like to know that total number so that when we're cashing out, we could just do a quick check to see if we have the right number of items in our cart. Well, to do that in SQL, we can use what's called an aggregate function. An aggregate function is useful for things like getting the maximum, minimum, sum, and average of values in our database. In this example, to get the total number of items, we'll start with select, then the name of the aggregate function we'll be using, sum, then the name of the column we want, and then from the name of the table we're selecting from. Ta-da! So you can see on the right that the sum is 15, so we should have 15 items in our cart if we got everything correctly. And notice if I go up here and change the number of bananas, because I'm going to invite my monkey friends over for a jungle party, we can see the sum increase in real time and get bigger and bigger, so we know that we're now going to need 67 items in our cart. Now we could easily try out other aggregate functions here, because sum's not the only one. So if we wanted to know what is the most that we'll be buying of any one item, then we could use max. See, 56. Those are obviously our bananas. But this information is useful for this case. Let's go back to sum. Okay. Now, what if we wanted to make sure we had the right number of items after each aisle? Well, we can do that in SQL using the group by clause. We add it to the end of a query, specifying the column name to group by aisle. Okay, so now we can see that in one aisle we have 9, another of 1, but I don't actually know which aisle we're getting each of them in. So what we can do there is just add aisle to the beginning of this select. So there you can see, okay, so we're going to get 9 items in aisle 2, 1 item in aisle 4, 56 in aisle 7, and 1 in aisle 12. Awesome. Now, how did that actually work behind the scenes? The SQL engine first did the grouping of the rows based on aisle. So first did this group by, then it summed up the quantity in each of those groups, And then finally, it selected the first IO value that it saw in each group. And, you know, the IO value was the same for all of them, so we got the IOs back out. But we could have also said name here. And we do see a name for each of the rows, but it's a bit misleading because for some of these IOs, there are actually multiple items in that group, but the SQL engine just picked the first item out of it. So you really shouldn't be using something different from what you're grouping by, because you might not get a sensible result. So we'll say IO, and now that's an accurate presentation of our data. Okay, so great. You've seen aggregate functions, you've seen group by, and now you can efficiently gather useful statistics on your data. Another tool for your SQL toolbox.
Nothing really for me to add on to this one. Group by is just going through this and, you know, sorting the data into groups. And then the advice is usually pretty sound of whatever you're grouping by should be a part of your select so that you aren't getting some data that it was accidentally grouped together that you thought represented the whole thing. So go ahead and move on to the challenge. We have a to-do list. It says insert another item to your to-do list with the estimated number of minutes it will take. And then the second part of it will ask you to select out the sum of minutes. This one should go pretty quick for you. The poll is started. I'll only give you a minute or two because this one is an easier challenge. All right, most of you guys have voted in. So in order to insert another item, we're going to follow the same format as the inserts right above it. Insert into to-do list. Notice that table names cannot have spaces in them, so we use an underscore. We will add our values in. We need to make a unique ID. We're going to say SQL learning, and then we're going to add a time of 60 minutes onto that. And then on to the next step. We need to select the sum of minutes. So all we need to do is select sum. Sum is a keyword. We will say minutes. We need to specify from the to-do list table. And just like that, we have it done. Any questions? Joke.
At this point, you've probably heard me pronounce SQL two ways, SQL or SQL. Some of you might even be mad that I'm pronouncing it one way or the other, and you may have very good reason for believing that your favorite pronunciation is the correct one. So what's the deal? Well, SQL was originally invented at IBM in the early 1970s, and the first version was called SEQUEL, and it stood for Structured English Query Language. That acronym, SQL, was later changed to SQL because SQL was already trademarked by an airplane company, and companies really don't like getting into trademark lawsuits. Nowadays, many of us still pronounce it SQL because it's shorter to say, and we've got historical reasons to claim that it's the right way. However, when I surveyed developers across the world, I found that in non-English languages, many of them pronounce it SQL, or, for example, SAQLA in Spanish. Since our videos get translated here on Khan Academy, I figured I'd make it easier for translators to match the pace of our videos by pronouncing SQL the long way. But in everyday life, I'm used to calling it SQL, so both of them come out of me. Now you know, it can be SQL or SQL, and you'll probably hear both the rest of your life. The world is a messy place, but at least you now have a way of structuring your queries about it, right?
So both are accepted. They're pretty much interchangeable in the United States. So no right way or wrong way. And I do use them interchangeably. I will usually say SQL just because it's easier to say. But SQL is an acronym for structured query language. So either one is totally fine. Okay, we aren't going to do the projects here, although if you are looking for a little bit extra practice, the projects are a great way to get that practice and to kind of challenge yourself, think a little bit bigger on those. If you do get stuck on any of these projects and would like help on them, of course, you can schedule a one-on-one with me or shoot me a Slack message with your code and the name of the project that you're working on, and I can try and help you on it. But we will skip these for the sake of time. You do not need to do these. These are totally optional. Moving on.
I've spent the last few talkthroughs making a grocery list. Well, now that I've realized how much eating I do, I realize what else I should be tracking in a database. How much exercise I'm doing. So I'll start by pasting in some statements that create a table and insert a few rows of data. Let's see what I have in exercise logs. We have an ID, of course, a type, which is a string like biking or dancing, minutes for how many I spent, calories for how many I burned, and heart rate for how high it went. Now I'm inserting the data using a slightly different syntax than before. Notice how I'm specifying the column names in parentheses after the table name. When I do that, it means that I don't have to specify every column value here. I only have to specify the ones that I give in this list of column names. Now, do you see which one I didn't specify here? The missing column is ID, and that's very much on purpose. ID, here we go. The ID column is the primary key in the table, and it's set to auto increment. That means that the database will automatically fill it in for us when we tell it to, by picking an ID that's different from the other rows in the table, usually a number that's one bigger than the biggest number so far. Now, I would rather have the database figure that out than have me figure it out. So I usually like to do my inserts this way, leave out the ID, let the database do that work for me. Okay, so there we go. My database table is set up, and it looks like I've even done a bit of exercise. Go me! Let's find out where I'm burning the most calories with a simple query. I'll just modify this one. So select from exercise logs where calories greater than 50, and we'll just order by calories as well. Okay, so I've done 2 activities where I've burned more than 50 calories, and it looks like dancing burned the most. Now, I want to find out which activities I've done that have burned more than 50 calories, but also taken less than 30 minutes, because I want to exercise more efficiently in the future. It's pretty obvious from looking at the current results. There's only 2 results. It's easy to look at that. But Just imagine that there are thousands of rows. Maybe this is data from thousands of users. I would need a way to filter that down in the SQL query itself. To do that, I can use the AND operator to combine those multiple conditions, like to only return the rows where calories are greater than 50 and minutes are less than 30. Haha. So now I only see one result, dancing, which means I should just spend my whole life dancing, which sounds pretty good to me. Okay, so in a similar way, I could use the OR operator to return rows that meet any of some conditions. Like, let's say rows where calories are greater than 50 or heart rate is above 100. And that helps me find the most vigorous exercises. Now we can see that dancing and biking are both good, and actually I do like biking. It's just a bit harder. Now you can have as many OR and AND operators in your query as you'd like. The AND operator has precedence over the OR if you've got both of them in the same query, but you can always use parentheses to change the order of evaluation, just like with math expressions. Now I want you to try these out in the next challenge and stay tuned for the next talk through where I'm going to show how to do some interesting things using this type column here. See you then.
All right, so this is the last challenge we'll do before we go on break. It is a karaoke one. For the first step, you're going to select all the song titles, and then you will start chaining your where statements there. And as always, don't forget to vote in the poll when you are done. Just to note, the duration column is measured in seconds, not in minutes. So you might need to do some math there. Believe it or not, there's actually a date format that measures dates in the number of seconds since 1970. So all kinds of weird date formats that you can run into across different databases and programming languages.
What's the there's like a 2039 problem or something, or maybe it's 2139. So a problem coming up like relatively soon.
Yeah, we're approaching the amount, we're approaching the
base 64 or something like that for
or UN8 storage of 2038 numbers, but it's basically the year 2000 issue where computers weren't set up to process dates starting with the number 2, or the year starting with 2, and everyone panicked. And then it turned out that because we have update mechanisms, it's not the end of the world, literally, that some people thought it would be. And they just pushed out updates because they knew that was going to be a problem 3 years before it actually happened, and pushed out updates everywhere. So it only impacted computers that didn't get updates run to them. There may be another, they call that the epoch. So there may be another date format that uses 1971, but 19 or January 1st at midnight is the one that I primarily know about.
yeah, I think that's the one I was talking about. Maybe there's something else with 1971.
Yeah, if it's signed in a 32-bit value, it covers 68 years after the epoch, and that means that it can only go as far back as 1901 and all the way up to 2038. JavaScript does not handle dates in that format. So it's not really a concern, and obviously there are utilities built to convert from any one date format to any other date format. But there's a great YouTube video that Tom Scott, I think his name's Tom Scott, did on dates, which lets you see how absurdly hard dates are in programming, and why you usually want to use a library to handle them instead of trying to build your own, that handles a lot of those weird edge cases. Okay, let's dive into this. Select all the song titles. Pretty easy. Select title from songs. First time that we aren't using a wildcard, we're using the column name. Move on to the next one, which is add another select that uses or to show the titles of the songs, or that have I'm sorry, where the songs are either epic or released after 1990. So we're going to say select title from songs where the mood is equal to epic. Notice this is not a triple equals here, or where it was released after 1990. And just like JavaScript has its own syntax, so does SQL. So we're using quotes for strings, and we're not using quotes for numbers. Don't forget your equals. Greater than 1990, not equal to 1990. Select title from songs. My God, I am just missing words left and right tonight. Okay. Last thing we need to do is where it's released after 1990 and less than 4 minutes long, and then it does say note the duration column is measured in seconds. So because that is very similar to this one, we're going to paste that in and then just add an and keyword and say duration is less than, and we can say 4 times 60 here, and that should get us the same result. Or we could just change this out and say less than 240. And epic released and duration. Seriously? Oh, and we are good to go. Okay. Let's just go on break a couple minutes early because I don't know if we'll have enough time to do the video and the next challenge after that. So let's go on break, be back at 7:15, and we will keep on going with the SQL lesson. All right. On to inquiries, where things get a little bit trickier.
I'm back with my table of exercise logs.
I was sharing my screen, wasn't it?
I'm back with my table of exercise logs, and I've added a few more rows. Now, if I wanted to filter these logs to just show my biking logs, I could just add where type equals biking. Simple. It's getting sunny outside, so actually what I want to find is all of the outdoor activities, not just biking. So to do that, I can use the OR operator that we just learned, checking each of the different outdoor types. So type equals hiking, or type equals tree climbing, or type equals rowing. Unfortunately, I don't yet have a mountain or a tree or a lake in my home, so all of these are outdoor activities. All right, so that worked, but there is actually a simpler way to do this query, and that's using the in operator. The in operator will check to see if a particular value is in a list of values. Let me show you. So we'll take this query and I'll paste it, and then I'm going to replace this equal sign with in, and then put a parentheses, and then I'm just going to separate each of these strings with a comma instead of that whole long or type equals blah. Ta-da! Same results like we expected, but this query is easier to read and it's a bit shorter too. We could easily also do the inverse query if we just want to see the indoor activities. We just write not in. Ha. So that's just dancing, and I'll save that for the winter time. Let's change it back to in and our outdoor activities. And I'm going to show you something a little more interesting that we can do with in. First, I'm going to need another table of doctor recommended activities. I'll paste in the SQL for that. Let's see, where do we have it? Here. So here we've created a table of doctor recommended activities, which just has a type, which matches our type from up here, and a reason, which is why the doctor recommended it. Now, what if I wanted to see all my exercise logs that correspond to doctor recommended activities? Well, first, I might want to see what are those doctor recommended activities. So select type from doctor's favorites. Okay, biking and hiking. So I could just take this query and modify it and just shorten it to biking and hiking. However, if the doctor's favorite tables changed, like there was a new row added or a row deleted, then this query would be out of date. What I want is for this query to always be up to date with what's in this table here. So what I can do is use the in operator directly with the results of a SQL query, a select query. And it's actually very simple to do. I'll replace what's in the parentheses with the query that we did before. Ta-ta! Cool. So we call this inner query a subquery. It's the query that we're doing inside the outer query. And now this query will always pull based on whatever's in the doctor's table at the time. It will stay up to date. And this is a pretty simple subquery, but it could actually get really complex. It could be as complex as any of the queries that we've learned so far. Let me show you an example. What if we only want to select the favorites that the doctor recommended for cardiovascular reasons? So we could say where reason equals, and then we could paste this whole long reason in here, and we see hiking. But what if for some reason we didn't have the period in here? Well, now we actually see nothing for that query because it's trying to do an exact match and it can't exactly match that. So there are times like this when we want to do an inexact match, and we can do that with the like operator, which is a pretty neat operator. And so to do that, we're just gonna take this and I'm gonna replace the equal sign with like and get rid of, because all we care about is that very important word cardiovascular. That is what we're looking for. So we say cardiovascular and we also put a percentage sign on either side, which acts as a wildcard. So this should match any rows which contains the word cardiovascular anywhere, and it did. Yay! Okay, so that's pretty cool. Whew. We covered a lot in subqueries like. Hopefully you're pumped to try them out in the next challenge, or take a break, go climb a tree, and come back. Either way, I hope you have fun with it.
Okay, so no climbing trees. Class isn't over for another hour and 8 minutes. Then you can do whatever you want. Until then, we are working with the inquiry, right? So think about in as kind of being like an array where you can say where it is in this list of things, or an inquiry can be used to be based off of another query. So where the results of this one query are in the results of this other query. And then down here, we use a like operator. Think about this as kind of like a regular expression in JavaScript, which we haven't spent too much time on. It's basically a wildcard, right? Where we're saying the percent is saying anything can come after it, or anything can come before it, or anything can come after it. So we're just using more advanced ways of filtering down our data. We're still using the where keyword, but when we use where combined with in and like, we're able to filter down based off of results of other tables or other queries, and based off of things like wildcards. In JavaScript, we would do this in a regular expression. We would say period asterisk. In SQL, we use percent as the wildcard sign. So go ahead and do your playlist maker challenge. This is filtering down based off of a bunch of different songs that they have inserted. And this one is a 3-step one. And as always, when you are done, go ahead and vote in the poll. And I just saw something in chat. Oh, I see. start you out easy on this one and then get you going on the trickiness. Keep working on it, give you another minute, and then we will dive in. All right, let's try and go over these. So for the first one, we're just doing a basic where query on these. We've seen these before. It wants us to select the title column. So we say select title from our songs list where the artist is equal to Queen. And that gets us our first one. Next one, it says make a pop playlist, select the name of all artists from the pop genre. So again, another pretty easy one. Select the artist name from the artist table where their genre is equal to pop. And so we want to be referencing the table, right? We want to make sure that we've got the column name right. We know that what we're filtering by. And if we ever weren't quite sure, we could always do something like select star from artists. Table name is called artists to get the results of that table. And then from there, we can filter down from that. So we get our select star name artists, and we are good to go. On to the final one. If I remember to hit the next step button, there we go. Finish creating the pop playlist, add another query that will select the title of all the songs from the pop artist. It should use an in-nested subquery. So the problem that we're having here is that the genre of that artist is only stored in the artist table. We don't have the genre of the song based off of the artist. So this is the first time that we really make a relational query, right? We are using the genre data in another table, overlaying that with a subquery into the songs table to make sure that all the songs we're selecting are only from pop artists. So the way that we do that is we say select title from songs, because we need the song information, right? What we're trying to get here is the title of the song, and that is in the songs table. But then we need to say where the artist, what artist, the artist in the songs table is listed in where? Listed in select the artist name from the artist table where the genre is equal to pop. Okay, so let's break that down. We said select title from songs. And again, if we do a select star from songs, we're able to see that the songs have the artist name and the title, but no genre. And so what we're doing is we're saying title from songs where the artist, so we're overlaying this column with the column from artists, which looks like this. And so we're saying overlay this name column with the artist name column. That's what we do here. We say, hey, the name from artists where the artist in songs lines up with the name in artists. Then also filter down in the artist table only where the genre name is equal to pop. Anyone have questions on that? Okay. Moving on.
Let's continue with more queries of my exercise logs. Let's say that I want to see how many calories I've burned for each type of activity. We can do that with an aggregate query. Say select type and then sum calories from exercise logs, and then we're going to group by type. Now I can see each type with how many calories I've burned total for that type of exercise. Now, do you notice how the column shows up as sum calories in the results? If we want, we can actually tell SQL to give that column a new name just by writing as and then giving it the new name total calories. That can make our results easier to read, and it also has another benefit, which we'll use later. So next, I want to filter the results to only show activities where I've burned more than 150 calories total across all the times I've done that exercise. It turns out that 150 calories is the amount in 1 ounce of dark chocolate, so it seems like a good amount to shoot for. Now, my first instinct might be using where to filter. Like if I took this query here and then said where calories greater than 150, then we only see dancing and we don't see biking, which we would expect to see. The reason we only see dancing is because it filters each individual row that comes in. And dancing is the only exercise where I burned more than 150 calories in a single log. But what I want to know is which exercise type or types have I burned more than 150 calories across all of the logs for that exercise type. We actually have to use something new for that, which is the having clause. To use that, we'll remove this where, and then after the group by, we'll write having, and then total calories greater than 150. Ta-da! Now we see biking, because now it's actually looking at the total calories, and I've indeed earned more than 150 over time in my logs. So as you can see, those two queries are actually different, but they are easy to confuse. When we use having, we're applying the conditions to the grouped values, not the individual values in the individual rows. We could use any aggregate function on a grouped column that makes sense. Sum, min, max, average, whatever we want to check. Let's do another example. So if we want to see the average calories for all the exercises where we burn, let's say more than 50 average total. Oh, that's all of them. So let's up it. 100 in the middle, still doing good. 70, cool. So you can see we can play around with that query there, get different results with that having. Now let me do something a little different. Let's say we want to see all the exercise where we logged at least 2 activities for that type of exercise. For that, we're going to use a count function. So I'll select type from exercise logs, group by type, and then having count star, doesn't matter what column, so we can just do star, greater than or equal to 2. Okay, so now we can see biking, dancing, tree climbing. I've done all of those at least 2 times. Makes sense because those are my 3 favorite activities in life. Besides coding, of course. Okay, so now you've seen having. Remember that it's easy to confuse having with where when using these aggregate functions. So think through your results and make sure they make sense. And now you get to try it yourself.
Okay, nothing major to add to this one. We're going to run right into the challenge. So you want to use group by and having kind of separate those out. Go give it a try. Poll is live, and then we will go through it in a couple minutes. Think about group by as literally creating groups to create sums off of, and then think about having as being the where, but based off of the summed or the grouped results. It's kind of how I think about having and group by. We don't use them a ton in day-to-day SQL because we would do that combination in our JavaScript, but it is very helpful to get groups of results back together. So again, group by is literally like sorting and grouping them into like little sub areas of the table. And then having is filtering the results based off of the groups that we just created. If you did get this challenge done, feel free to play around by taking the group by and the having out, write some select queries, right? See what happens when you take the group by out, see what happens when you take the having out, try and do it with a where filter. Just try and compare basically why the group by and the having are necessary compared to just using the where. Guys, one more minute to go through this and then we will try it together. All right, let's go ahead and work on this together. So for the first one, we are trying to find all the authors who have written 1,000 words or more using both group by and having. So it's really important that we, again, understand this table structure. So I'm going to select star from my books just to see everything that got created, right? And what we see in here, no, I don't think it's actually Laura. That would be a very weird coincidence. I don't think it actually is, but they do have similar voices. Okay, so in here, we've got our author, the title, and the words that they have that are in each book. So we know we're going to need to sum up the words in order to know how many they wrote. We also want to get the author's name so that we know who the sum of all of those words belong to. The problem that we need to do is we need to tell SQL, hey, all of these authors are basically grouped together. So the way that we do that is we say, instead of select star from books, I'm going to get the author and the sum of all of the words. I am then still going to do the from books, but I am going to say group by the author. And that way I'm able to, if I take this out, you'll see that we only get one author there, right? Because it doesn't know how to group these things together. So it is giving me the sum of all the words in all the books written by all the authors. And I'm like, well, that's not helpful. So what I want to do is I want to tell it, hey, that author, group it by the author's individual names. Now, if we add all three of these together, we'll get the sum of all of the words in the table, but this is what is breaking that out. Now I want to filter that down to just authors that have more than 1,000,000 words. Well, I can't do a where the sum of words is greater than something because it's based off of the group. So instead, what I'm going to do is I'm going to say, hey, this sum we are going to call total words. That is what is called a column alias, right? It's basically just renaming the column. Then we can use the having total words here that lines up with our alias. And because it is now grouped properly and we have a name on that column, we can type in 1,000,000 and see what authors have written more than 1,000,000 words. Any questions before we move on?
Yeah, I need you to go back with me one more time because I did not like get that at all.
Okay, so let's take a step back. I'm gonna go into the select sum and words as total words from books. The problem with this sum is that it doesn't know to group the sum by each individual author. So what we're getting right now is the sum of all words of all books in the database. So what we want to tell SQL instead is don't do the sum of all the words, instead do the sum grouped by each individual author. So when we add the group by here, it is now breaking that down and showing us the sum of all the words still, but for each individual author, grouped by each individual author, instead of doing the sum of all the books across all the authors. Does that make sense? Okay, now the problem is we can't just say where, because where is based off of individual columns. It isn't based off of aggregate functions like sum. So what we're able to do is say as total words here. What that is basically just doing is naming the column in the output. It is basically an alias, right? It's a shortcut to the column we selected. Because we now have that in there, we can use instead of where, we can say having. And that having is like a where filter based off of the group by. And so we're able to say having, and then use this total words here to say where total words is greater than 1 million. Good? Cool. And we get a little bit more practice. The next one, we need to do an average of 150 words per book. Your results table should include author and average words as AVG words column. Okay, so we do the same thing, select author. This time we're going to use AVG of words. And it says that we need to select it as the average words column. So we say as AVG words from still our books. This time we are going to still group by the author because we need 150 words per book, but we're going to say having AVG words greater than 150,000. So still grouping by author so that we are, because we aren't trying to take the average of all books, and we're not trying to take the average of one book. We're trying to take the average words per author. And so that's why we still do the group that way. And then the having is, again, like the where filter, but for aggregate results that we can filter down in here. Any questions? Okay.
Do we have
Oh,
to
go ahead.
keep do we have to like keep like uppercasing like the words like select, group, and stuff?
Very good question. No, you don't. SQL will recognize that, but it's kind of like an indentation thing in our code. While it isn't entirely required, it just makes it easier to differentiate out column names and table names with what we call reserved words in SQL. So it is tradition to capitalize reserved words, but it is definitely not a requirement. Okay. I'm going to summarize this because I wish they did this as a video, but it is really important. So why are we learning SQL in the first place, right? Like it seems like we could do most of this with just a spreadsheet. And in fact, when we get into database design, a spreadsheet is going to be the #1 tool that we use in order to understand like real world database design. So let's imagine you have an exercise app with 1,000 users. This lets users log in their activity, their calories, and their heart rate, right? Kind of similar to some of your capstones. They will have forms in them. The forms get submitted. Where does that form data actually end up? Well, it turns out that that form data is going to end up in a database. And we're going to need to be able to insert that data into the database, right? That is the C create. We're going to need to be able to read that data back out. We're going to use a select query for that. That's going to be so that we can show the user the data. We need to be able to update the data, which we haven't gotten to yet, and we need to be able to delete the data. So those are our 4 key operations: create, read, update, delete, or select. I'm sorry, insert into, select, update, where, and delete or drop. So we're going to get into the update or drop in a couple minutes or in tomorrow's class. But why do we use this? Well, software engineers clearly need to use this because we're building a web app with forms that data needs to get submitted at somewhere. Data scientists use databases because at a certain point, your data grows so big that it can't go in a spreadsheet like Google Sheets or Excel. And we need to be able to write queries in order to get the results that we want back out, right? Hey, COVID, we're in the middle of a pandemic, or we were in the middle of a pandemic. We need to know how many people have COVID, how many people are getting hospitalized. All of that data can't go into a spreadsheet to be analyzed. So, data scientists are able to do a lot of that. Terry, alter is only used for modifying the table structure. It isn't used to modify the data inside the table, if that makes sense at all. And I think they cover alter coming up if not in the next 30 minutes, it will be tomorrow. Product managers use a lot of SQL queries, right? So they may say, all right, well, we just created this new page that allows users to upload videos. I wonder how many people are using it. Well, could be millions of people using that product, and they may want to know how many people are using it. Or quality assurance may use it. I wonder how many people are getting this error message. That error message could be happening thousands of times a day. We need to write a SQL query to analyze our error logs to figure out what's coming in. So all kinds of information that can be used there. Any question about SQL queries? Or who uses SQL queries, to be more specific? Okay. We are going to finish this out, and then I will see how far into the next challenge we will go. The good news is if we go up to full time today, tomorrow I'm hoping to give you guys a couple minutes back at the end of class, but we'll see how far we get tonight.
Let's try a few more advanced SQL features. I've been logging heart rate for each of my exercises, and I haven't done anything interesting with this data yet. So now it's time. I did a little research on the internet, and I found that the maximum heart rate is 220 minus your age. So one thing I can do is query my logs to see if my heart rate ever goes above max, since that would be pretty scary, or tell me that there's something wrong with my heart rate checking device. Okay, to do that, I'm going to do a count star. So count star from exercise logs, and then where heart rate greater than 220 minus my age, 30. Woohoo, there's no results, and that makes my heart happy. Now, notice I'm using the subtraction operator, and in fact, I can use most math operators in SQL, like to add, subtract, multiply, or divide. And if I need to, just like in math, I can throw in parentheses and change the order of evaluation. All right, so we've confirmed that my heart doesn't go above max. That's good. Now let's look to see if my heart gets into the target heart rate zone. And that is 50 to 90% of max. So we're going to start with our count star, and we just need to change our where. So this time we're going to say heart rate is greater than, and let's look at 50% of max. So that's 220 minus 30. Okay, so you see I'm combining a few math operators here. And I'm going to also throw in the round function just to show you that we can use that function. It's pretty nifty. And then we're going to say and I'll just copy paste this and change it to less than 90. Let's go ahead and throw a equals in there. All right, so now we're checking to see 59% of max, and we see there are 4 logs that fall in that target zone. But what about my other logs? What zones are they in? We don't know. All we know is that 4 of them are in that target zone. The rest could be maybe they're 90 to 100%, maybe they're less than 50%. What I would really like to see is a summary of all my logs and how many were in each of the heart rate zones. Now that sounds like a situation where I would use a group by, like group by this column that says which heart rate zone this row is in. But I don't actually have a column like that to group by. Well, I can effectively create a column using the case statement. Now I'll admit that I find this the trickiest statement to use in SQL. So I struggle with it a bit, and don't worry if you find it a bit odd as well. It's similar to an if or a switch from programming languages, if you're familiar with those. Otherwise, don't worry about it. All right, so I'm going to use case, but I'm just going to start with outputting what we know, which is type and heart rate from exercise logs, and see what that looks like. Okay, now for each of these rows, I want to add a new column that says which zone the heart rate is in. To do that, I go into the select part of the query, and I'm going to write case to begin the case statement. Then I type when, and the first condition, which is checking if it's above max. So that was heart rate greater than 220 minus 30. Then I write then and an expression, which is just a string. So we'll say above max. Okay, so this is my first case. Now I'm going to keep going with my other conditions. So when heart rate is greater than 90, then we'll say it's above target. And then, so if greater than 90, and then we'll say at that point, if it's greater than 50, we can say it's within target. And everything else would be below target. So I could do another condition for that, but I can also just be lazy or smart, however you want to think of it, and say else below target. Okay, now my conditions are all done, but I haven't told SQL what to name this new column. For that, I write end as HR zone. Awesome. So now for each of the rows, I can see the new column with a nice description of what zone they're in. Now that we've done that, finally, I can make a query that summarizes how many of my logs are in each of the zones. And that is a whole lot easier now that I've set up this case. I'm just going to take this query here, copy it, and I'm going to group by the new column we created, and then add count star, get rid of the heart rate, see what we have here. Aha! And now we see that we've got 4 below target and 4 within target. That's pretty neat, huh? That case statement, it is a tricky one, but it sure is handy once you get the hang of it. You may not use it all the time, but it's good to know just in case.
You why I like this woman? All the puns? All right. So case statements, kind of like an if statement now built into our SQL query, right? So we are able to still use things from our select. We're able to use some math queries in here, but we're also able to break it down even further to basically use inline if statements as part of that. And now you're starting to see the power of SQL, right? We can layer everything on top of each other to really start to build everything up. So go ahead, take on the gradebook challenge. I don't know why that took me to the project. Go ahead and try and work on your gradebook. Poll is restarted. And I think we will end here for the night just because it's a good stopping point. So once we get the challenge done, I will let you guys go. Tomorrow we will pick up on the last part of these units in lesson 2, which will be updating and deleting data into the database. And then we will also get practice with our relational queries as well tomorrow night. All right, which one of you voted for never vote for me?
I think it might have been me by mistake. I'm not sure.
Oh,
I was
it's all good. No problem.
yeah, I'm literally like looking at like W3 school trying to get like get like some like the key words that we went over and stuff. So my bad.
That is a really good note. W3 Schools, just like JavaScript, has a really good section on SQL. So if you do a search W3 Schools SQL in Google, you will obviously end up there. W3 Schools also does have a SQL tutorial. So if you're looking for supplementary learning material, you are welcome to go to W3 Schools. And then they will give you, the same intro of what it stands for, the history behind it, all the things that you can do. They'll show you using SQL in your website. And then RDBMS is a relational database management system. If you hear of RDBMS, they just mean a SQL-based relational database. And then you'll see that they go into things like selects, and they've got something similar to Khan Academy where you're able to run the query and see the results of it. And then you're also able to like investigate into their database by clicking on any of the tables and seeing the data come up. So until we get our local environment set up, this can be a really helpful way to get a little bit more practice. And then obviously they do have a breakdown of all of that. So if you get into something like a SQL like, this will remind you what the like is doing from Khan Academy. We will get into things like joins tomorrow. We're doing cases right now. And then we'll also get into update and delete tomorrow. But really good resource, supplementary resource for that. So thank you for bringing that up, Terry. All right, let's finish this up for the evening so you guys can get out of here a couple minutes early. So the thing says we need to select all the rows and display the name, number grade, and percent completed, which you can compute by multiplying and rounding the fraction completed column. Okay, so we are dealing with ID, name, number grade, and fraction completed, all from our database. And as always, just like we can do a console log, we can do a select star from our student grades to get an idea of their name, their number grade, and then the fraction completed, right? How many assignments they've basically finished. So we are going to, they said they want the student's name selected, their number grade selected. Come on, let me type number grade. And then they said their fraction completed, which you can compute by multiplying and rounding the fraction completed column. So because the fraction completed is a decimal, we don't want it as a decimal. We want it as a whole number. So we are going to say, hey, take fraction completed, multiply it by 100, which moves the decimal place over 2 places, and then round that out to the nearest whole number. The table that we are doing all of this from is our student grades table. And the last thing they said is the column should be percent completed. Well, this column is round fraction completed times 100. So all we need to do is alias our column as percent completed, and we have finished this off. Any questions on that one? Okay. Last one. The goal of this table is to show how many students have learned which letter grade. You can output the letter grade by using case with the number grade column. A is above a 90, B is above an 80, C is above 70, and otherwise they fail, no D's in this class. Then you get to use count with group by to show the number of students with each one of those grades. Okay, so a little tricky. We are going to do a select. And then they want us to use count with group by to show the number of people with those grades. So we're going to say count basically everyone, but we're going to do different cases. And we're going to say when the number grade is greater than a 90, then they get an A. When the number grade is bigger than an 80, then they get a B. When the number grade is greater than 70, then they get a C, else they fail. Then we need to end our case statement and tell it that that column is all going to be called letter grade. We finish this up, we say from student grades, because that's our table's name. And then we're close to the finish, but we still have to do a group by. Because if you notice, without the group by, we get 6 people with the letter grade B. And it's like, how is that even possible? Well, what we need to do is group by here so that the number grades are separated out so that we know how many people got an A, B, C, and F. So we just come down in here and we say group by the letter, group by the letter grade that we aliased right here. And that tells us we have broken this down. One person got an A, 3 people got a B, one person got a C, and one person got an F. So we have to do that final group by so that it isn't doing a count of all the grades. It's doing a count based off of the cases that we set up here. With all of that said, that feels like a pretty good stopping point for the evening. Does anyone have any questions on SQL up until this point? All right, we got one more day of this. We've got to still learn inserts, updates, and relational queries. Once we get those finished up, we will switch over to getting SQL installed on our computers and dive into making our very first APIs that are going to be interacting with our SQL databases. Next week, we will be diving back into the chat application. We will be building our first API that is interfacing with the database and also relaying information to and from the front end. And from there, it's just project after project until you guys build the confidence to get it into your capstones. So have an awesome evening. If you have any feedback on this, feel free to fill out the 30-second feedback form. You don't need to send completed screenshots if you are in Zoom with me tonight. If you would like to skip class tomorrow, though, the offer is still on the table. Finish out the rest of the challenges in Unit 3, which is all of the SQL stuff. You send me screenshots of basically this page that has check marks next to each one of the challenges, which is the little play icon. If you Slack me that, you do not need to show up for class tomorrow. Otherwise, have an awesome evening. I will see you guys either tomorrow if you want to go through these challenges together, or if you complete it asynchronously, you can and I saw the message. This month's open hack unfortunately got canceled, so you're stuck with me for another day. Mike's on vacation and didn't pass the torch to someone else, so no open hack for you guys. I will do an office hours on Saturday or Sunday, though, if you would like to meet up. All right, that's all I got. Have an awesome evening.
Don't you leave me now.